So in this video, I want to talk about question 7 from the 2014 final exam. So here's what f does. What it does is it takes a string that's like that and it decomposes it into elements that are separated by the separators. So what you'd get eventually is you'd get this kind of list where here you'd have 23 and then the next element is going to be plus, and then you'd get a 5 and then you'd get a times 7 minus 2 plus and a 3. So that's what you want to get, and then you'll process it further in question 8. So here's the idea for how to approach it. So what you would do is you would say, okay, so first we'll take the string and we'll transform it into this kind of thing where we just separate out the pluses. So it's gonna be like this. It's gonna be 23 and then the plus is separated out, but the times is still like that. So it's going to be 5 times 7 and then a minus 2 here, and then the plus you leave out, and then a 3, and then you want to also keep the pluses in between. So it's going to be like that. And what you'll do in the next stage is you'll say, okay, so I'll go over each of those strings in this list, and then I'll split each of those elements in the big list by the times. So this is going to get transformed into, so everything here stays the same, the plus stays the same, so up to here everything should stay the same, but then this is going to get transformed into 5 times 7 minus 2. So it's going to be 5 and then a times, and then a 7 minus 2, and then a plus again, and then a 3. And then you do the same thing, but with the minus. So all that's going to affect is this 7 minus 2, which is going to transform into 7 minus 2, like that. Okay, so let's write this function. So I'll call it f in the same way that it's called in the exam, and it's going to take a string and it's going to take a list of the splitters, of the separators. So the first thing that I want to do is I want to take the string, so this kind of string, and just put it in the list, because afterwards all of our elements are going to be contained inside lists. So it's going to look like this. And what I'm saying now is I'm going to go through every element of result. So it's going to be, maybe the intermediate result is going to be kind of like that, and I'm going to go through this, and then this, and then this, and then this, and then this, and if I want to split on the minus, then I'll see, oh, there is a minus in here, so this one I'll change, everything else I'll leave alone. So that's what I'll do. So for every possible splitter, so for E and L, so E is going to be plus and times and minus and things like that. Here's what I'll do. First, I'll save my previous results. I'll do a deep copy of results, and now I have my previous results, and now my fresh results are going to be just the empty list at first. Now what I want to do is I want to go through every element of this new result, which is basically the transformed string. So that's what I'll do. So I'll say for subres in the previous result, the new result is just empty for now, right? What we'll do is we'll say, okay, so we'll try to split. So think of an example where E is, for example, the plus and we're the times, and we're starting with this list, right? So we'll try to split each of those guys on the times operator, and we'll see what happens. So we'll say split list is subres split on E. So we try to split the 23 on the minus, on the times, sorry, and the plus on the times, and we try to split this expression on the times, which is actually going to work. And now we'll say, okay, so let's assume that it worked. Let's assume that we got a list that's larger than 1, because of course if you just split a string that's like that on something that's not in the string, let's try to split that on Z, then what you'll just get is a list that just contains the string. Okay, so let's assume that we tried to split something like that. So we tried to split, for example, 5 times 7 minus 2 on the times, and what we got is something like that. So then we need to go through every element on the list, and we got to append it to result separately. So that's exactly what we'll do. So say for I in range length split list minus 1. What we want to do, is we want to append, for example, the 5, and then we want to append the times, and then we want to append the 7 minus 2. But the last one, we don't want to append the times, so that's why I say length of split list minus 1. So I'll say result, extend, split list I, and then E. So for every one of those, so for every one of the 5 and the 7 minus 2, except for the last one, I'll append the element, the 5, and then I'll append the splitter. So in this instance, the times. It's going to be extend like this. And now that we're done, I can say, okay, so let's append the last element, which doesn't need the splitter after it. And that's it. So after we've iterated over all the splitters, we can just return result. Super resolution. I don't do super resolution 320. I don't think so. Maybe briefly mention.
How do you do that?
Do super resolution. Oh, actually, sorry. We do that. Well, I mean, one thing one thing you can do is you can sort of say, so if you think, so I mean, so you can't in general, but you can like impose a model on the image. So like one possible model that you impose on the image is the edges are always sharp. Right? If you happen to know that the edges are always sharp, okay, fine. You can do it. Then you can sort of mathematically just say, okay, so we remove sharpen all the edges with whatever method we have, and that's super resolution. One thing you can do is you could say, and again that's true, the image is composed of basically small patches, and the patches can't be just any random patches. The patches must be like there's lots of them, but they're not all the possible patches, right? So what you do is you say, okay, so I'll replace everything. So I'll take any patch in my image, and I'll look up in the patch of in my database of patches which I know are sharp. I'll find the closest one, just replace. And for some stuff it works amazingly well. So if so, for example, for pixel art, right?
So I was doing this thing by this guy Neil Toronto. It's interesting. This is like 2009 super resolution via image recapture and Bayesian effect modeling.
in effect.
Model.
I don't know.
Oh, that's so good.
So yeah, so check this out. So like you take, so like this is an actual thing where take this as an input, and you could use this as an output. And that's like not, I don't know if you can see from this part.
Oh, yeah, I can.
But and that's done by just matching, by just saying this is a series of patch, well, not a series, sorry, this is just a bunch of patches which are stitched together, and then for each, like the patches are just 3 by 3 or 2 by 2 or something like that. You just find the closest one that matches, and then just replace whatever you have in the image with that patch. And because for pixel art, that's a reasonable assumption, you have sort of sharp edges at defined scales. Yeah.
How this things like implemented in Photoshop, I'm just saying?
Oh, in Photoshop, do they have super resolution in Photoshop?
You know, when you have all these things, I never encountered them like like it's easy to use apps, but maybe
Well, like none of that works that awesome, right? So like this works awesome, but that's just because it's pixel art.
right.
Like there is not.
But this is the kind of thing that's what I want to take pixel art and
Yeah. Yeah, I don't think like.
you go online and like plug it in, like is there a pixel art app
Oh, like.
online or web interface? So you have all these techniques, I just don't know. I guess what I need to know is what can we easily accomplish nowadays?
I like all of those.
It needs to be a like just maybe a catalog of these things.
Like for most of those things, it's like I don't think like most of them are implemented actually, just because like it's. I mean, like for like a research kind of thing.
Someone writes a paper and then maybe this makes its way into, like this here is talking about like DVD signals, how to convert V to HTTP, stuff like that. So maybe some commercial things that like use it as part of their.
So like most of them are not because